Hello everyone and welcome back. My name is Mr. Kowalt, and in this video we're going to go over how to determine the equilibrium constant K for the following species in water. So let's get into this. So for this particular species is the Cn minus cyanate ion there. So we're gonna figure out, well, what if I took some of cyanate ion, if I put this in water, what would be the K value for this? What would be the equilibrium constant? And so in order to answer these type of questions, it's going to be useful in a lot of these cases to know this equation or this relationship. So we have the equilibrium constant of water is equal to the equilibrium constant of the acid multiplied by the equilibrium constant of the base, where the acid and the base here are related to each other as conjugates. So this would be conjugate acid, conjugate base pair. And so we can use this relationship here to help us determine what the K value is for a particular species. So let's take a look at the Cn minus. Now Cn minus is the conjugate base of a weak acid called hydrocyanic acid. So we have HCN, right? So here we have the weak acid, here we have the conjugate base of the weak acid. So how could we find the K for this if we know this? If it's the conjugate base, or if this is the conjugate base of the weak acid, well, we can look up the Ka value of the weak acid here. So when we do that, we find that the Ka value for hydrocyanic acid is 6.2 times 10 to the negative 10. So we have 6.2 times 10 to the negative, a negative 10 here. And we also know that, or you should know, that the Kw, or the equilibrium constant of the autoionization of water, is going to be equal to 1 times 10 to the negative 14. So we know that Kw is equal to 1.0 times 10 to the negative 14. And so in this case, we can now plug in and solve for the Kb, which is going to be the K value for the conjugate base. So here we take Kw, which is 1.0 times 10 to the negative 14. That's going to be equal to the Ka value, which we said was 6.2 times 10 to the negative 10. And we're going to multiply that by the Kb. Now all we need to do is just solve for Kb. We're going to divide by 6.2 times 10 to the negative 10. Divide this side by the same number, 6.2 times 10 to the negative 10. So that cancels out, and we get Kb equal to this. When we calculate this, we get Kb is equal to 1.61 times 10 to the negative 5. Let me double check that. Negative 5. So that is how you find the K value for Cn minus. Again, just to recap, you look at the ion, you recognize whether it's a conjugate base of a weak acid or a conjugate acid of weak base, and then you find the Ka or Kb value that you can look up easily, and then use this equation here to help you solve the problem. I hope this is helpful. If you enjoyed this video and you learned something from this video, then by all means like the video, share the video, hit that like button down there somewhere. Also, subscribe to my channel, hit that notification bell. When you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in your comment section, or my comment section, and let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.